Alright, in this video, we are continuing to talk about the solution of 3.2. When we talk about a graph, right, when there is a picture, the answer is in the picture. So fun thing about the first one, it will be the transformation. Now, everything remained the same, outside, inside. Outside is all about the y value, vertical movement, and the inside the parenthesis, that will be the x value, which will be the horizontal movement. So make sure use the no, okay? Now, when we go to the number 22 to 25, very good. So they would like us to check out the transformation. So activate your ego eye. You know that it will be the inside the parenthesis, and plus 1 just tells us move to the left 1 unit. Okay. I do want to point out my original log function that will be had to go through a point which will be what? 1, 0. That was my parent's function, okay? Now, when I move to the left side, it also moved my vertical asymptote. So when I move to the left side, as you can see here, it's 1 unit to the left side. Therefore, my function becomes this blue line, okay? Now, this is also tells us my vertical asymptote, it's right now become x equal to -1. So this is what you need to watch out for the definition, the horizontal asymptote. Okay, therefore, we will get this. 23. 23 was a good argument about that. We mentioned about the parent's function. When you see that, oh, I know that I need to rewrite this guy as a log base of 10 because the function had to be x first. So I have a -x plus 2. So now you see that, hey, I got it. Negative tells me will be a reflection, right? Left and right flip over the y-axis. That will be left and right flip that. Very good. Then plus 2 tells me to the left. No, no, no. Now, the mistake here, it is when we talk about the inside the parenthesis. Now, step 1, you're right. When I made the -x plus 2, but we mentioned about it is the inside the parenthesis. You are going to make sure I'm going to factor out a -1. So that becomes x minus 2. One more time. When you factor out this one, that will be -x will be -x, and negative become positive. So those two match, okay? Therefore, what you see is what you got. You will know that, the totally outside, the negative tells me it's a reflection, which means I'm going to flip left and right. Very good. Therefore, inside the parenthesis, by your awesome no, -2 here tells me is moved to the right 2 units. And that's why. Don't say that, Miss. Oh, answer key is wrong. The answer key is right, okay? Now, as we mentioned about the vertical asymptote, so this will become the trouble again, the vertical asymptote. It tells me x equal to 2 is my vertical asymptote. And again, if you lost, we can go through the original. The original function had to go through what? 1, 0, right? So this will be my parent's function. Now, I need to move that to the right side 2 units. So therefore, starting from this point, 1, 0, I need to move to the right side, 1, 2. So that become my function, move to the right. Now, what do we say? You also need to flip that left and right. So once you flip that, this come to here and this come to here. And that's why the final answer will be right here. So is it good? All right. Nice. Activate your ego eye. All right. All about the base. So do not overthink the natural law. Okay. E. So it will be a growth. Now, outside plus 2 tells me just move up 2 units. So nothing changed. So my vertical asymptote, as you can see, that it still be my x equal to 0. 25. Okay, so outside, inside, outside, inside. As you can see here, you can say that. So I know that. -1 tells me write 1. Good. Totally outside, it tells me I'm going to do a reflection, which means I'm going to flip upside down. So the upside down, what's that tells us? That will be the y value upside down. So therefore, you know that if you ever lost, we start from the parents function. The original parents function had to go through 1, 0, right? That's my original parents function. Now I need to move to the right 1 unit. So what you see here, it is this point had to move up here. So my function will become this blue. Okay. Now what do we need to say? I am going to flip that upside down. So seeing is believing. Once you flip that, this one is upside down, right? This one is going to upside down. So therefore, what you see is what you got. Your final answer, it's right here, is the correct answer. Good, 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 good. So make sure this is what we mentioned about. When there is a picture, the answer is in the picture. And with the knowledge of the transformation, we still can have fun of that. Okay, so 26 to 29, you can just graph that with your fancy calculator. So all about the base is 10, bigger than 1, right? So we know it's a growth, so growing up. Now, when you see here, that will be to the right 3. So original, my vertical asymptote should be x equal to 0. But because I moved that to the right 3, so now my vertical asymptote, as you can see, will become x equal to 3. So this will be something we call that, awesome eagle eye. So this is something you got to make sure, what do I know about that? The asymptote. And this, it's my vertical asymptote, okay? So the domain, as you can see, will be from 3 to positive infinity, and the range up and down, you can keep going, negative infinity to positive infinity. Do you see any open circle, jump gap? No, so that will be a continuity. You can chase my graph without lifting the pencil. And we mentioned about the base is 10, so it will be a growth, which will be a increasing, ooh la la. Now symmetric, what is a symmetric? Can you follow along the y-axis, x-axis, your picture will match up? No, so therefore it's none. Boundary, no. Remember what we mentioned about? When you look at your graph can keep going up as you want, can going down as you want. So there's no boundary. What do we talk about a boundary? For example, if I have a graph kind of like this one, okay? Now you see that, my lowest point for my graph is bound below. So this will be, I'm going to bound below by this number. Maybe I'm going to make this -10, okay? So therefore, this function will have a boundary bound below, okay, by this invisible line. Okay, extrema just tells you, do you see any maximum highest point or the lowest point, the minimum? Wow, what do we say? When we look at my log function, you know that, do you see the highest point? No, keep going. Do you see the lowest point? Keep going down. So therefore, there is no maximum, no minimum. So asymptote we talk about, controlled by the x, so we got it. M behavior, I do want to talk about the M behavior. Since you look at your picture, okay, the picture right here, it's my vertical asymptote, x equal to 3. Okay, let me clean this out. Now, M behavior, talking about to the left, to the right. All right, now, what you see here, the positive, it tells you it's from the right side. So from the right. So coming from the right, almost get to x equal to 3, coming from the right. What do you see my picture behave? You know that the picture is more and more negative, okay? And then if you take a look at my right side, which means x can equal to any positive number, keep going. And what do you see in my picture? It will become more and more positive. So that will be the definition of the symbol. The plus tells you it's coming from the right side, okay? All right, so the next one, as you can see here, once again, you are going to activate your eagle eye. Do I see anything change if I rewrite this? Natural law is E, but remember what we're talking about. The x had to come first, so that will be minus x plus 4. But, outside, inside. I need to rewrite this guy as my totally take out the -1. So everything I see here, you can say that, oh, when I distribution, I got -x, check, negative become positive, check. So this tells me what you see is what you got. -4 tells me my graph, aka it's my asymptote, it's moving from 0 to x equal to 4. And this is my vertical asymptote, okay? Therefore, my original was 0, but now it moved from to x equal to 4. That is my asymptote. Now you may say that, then what happened to the negative? Well, the negative tells me it's still inside the parentheses, so that means there is a flip. How do we flip that? It's inside the parentheses, so that will be left and right flip. So when you take a look at the original graph, you know that the original law had to go through the 1, 0. I had to go through this, right? But now I need to move that to the right side 4 units. So 1, 2, 3, 4. So therefore, this tells me my picture had to become this guy, right? Now you can say that, what's going on about the inside the parenthesis, the negative side? The inside the parenthesis just tells us I'm going to flip my picture left and right. So when I flip my picture, that will become left and right flip. So was it good? So that's all right. I do want to redraw the picture one more time. So again, remember what we talked about the asymptote. So the original was right here. That was my parents' function, okay? So when I at my point, we say that you're going to move that from the 0, right? My vertical asymptote, it's already moved to my x equal to 4, the vertical asymptote. So I know that my graph will need to follow, oops, that's beautiful, right? Okay, so now I have my vertical asymptote right here. Now I need to flip those one to the left and right because that was the inside the parenthesis negative. So therefore, that will become this guy. Left and right. So this will be my final answer for this graph, okay? So seeing is believing. So what will be my domain? As you can see, if you only look at the picture, my domain, as you can see, is from -infinity to 4. Remember, this is my vertical asymptote, check. And my range is -infinity to +infinity. Yes, it's continue. And yes, my picture is decrease. So therefore, that will be a decrease, okay? And then what do we know about the symmetric none and boundary? You don't bound by any particular number. Do you see a maximum or minimum? No. And then one more time about the M behavior. To the left, to the right. So again, the negative do not means -4. The negative just means from the left side of the number 4. So when you take a look at the number 4, almost right here, but coming from the left side. So this will be mine. This will be my graph. You see from the left side. What do you know about from the left side? My picture is more and more what? Negative, and that's why. Coming from the left side, my graph is more and more negative. Then what happened when you take a look at my x value? It's more negative, which will know that more and more negative. And what do you see? My y value, that will be more positive. Okay. All right, same thing as this one. As you can see that inside, outside, inside, outside. So this will be my totally. I'm going to move down 3, and I have a stretch, vertical stretch by a factor of 2. So this will be something we talk about. Hey, when there is a picture, the answer is in the picture. So once again, the plus side just tells you it's from the right side. Okay. Almost to 0 from the right side. So I do want to talk about that. The 0 is right here, but from the right side. What do you know from the right side? From the right side, as you can look at your picture from the right side, your picture, it's more and more negative. Okay. All right. The last one, as we mentioned about outside, inside, outside, inside. You kind of love it. That will be totally down 4. Right, down 4, and then left 3, and then you're going to flip that upside down. That's why the picture looks like that. Now, when you go to the increasing, decreasing, as x gets more and more positive, you do see your picture is going down, so that will be a decrease. Good. All right, and that's it. When we mention about there is a picture, the answer it's in the picture. So have fun. That's it. Awesome.